There is a place on Earth where a continent is being torn open. Not in a metaphorical sense, not as a headline trick. The ground is stretching, the crust is thinning, faults cut across the landscape, volcanoes rise from the fractures. And beneath it all, deep inside the planet, scientists have found evidence of something moving like a heartbeat. For most of human history, Africa looked permanent. A single, massive landmass, ancient, immovable, too large to change in any way we could ever witness. But in East Africa, that idea is wrong. From the Red Sea down through Ethiopia, Kenya, Tanzania, and toward Mozambique, the continent is splitting into two uneven pieces. On one side is the Nubian plate, on the other is the Somali plate. And between them lies one of the most important geological wounds on the planet, the East African Rift. If the process continues, the land between those plates will keep thinning and sinking. Magma may rise through the gap. A new ocean floor may form, and eventually seawater could flood in, creating a narrow ocean where there is land today. That future will not arrive tomorrow. It will not happen next year. It will take millions, possibly tens of millions of years. But the first stage is already visible. You can see it in the long valleys of Kenya, in the salt flats of Ethiopia, in the volcanoes of Afar, in the earthquakes that ripple through the region, and sometimes in sudden cracks that open across roads and fields, reminding everyone that the planet below us is not still. This is the story of Earth's newest ocean. Not a myth, not a disaster movie. A real geological event happening in slow motion right now beneath Africa.
To understand how strange this is, you have to start with a simple question. How does an ocean begin? Most of us imagine oceans as ancient things, permanent blue spaces that have always been there. But oceans have life cycles. They are born, they widen, they close. Their floors are created and destroyed. The Atlantic Ocean, for example, did not always exist. South America and Africa once fitted together like two torn edges of the same page. Around 138 million years ago, those continents began to pull apart. Magma rose into the crack, cooled, and built new oceanic crust. Over time, the gap widened into the South Atlantic. That is the basic recipe for an ocean. First, a continent stretches. Then the crust thins. Faults form. Valleys drop down. Volcanoes erupt. Eventually, the continent breaks enough that magma can create new seafloor. Then water floods the opening. The East African Rift may be showing us that recipe while it is still cooking. NASA describes the East African Rift as one of the great tectonic features of Africa, caused by fracturing of Earth's crust. In satellite images, the landscape itself seems to have been pulled apart. Parallel faults, steep escarpments, volcanic rocks, and chains of lakes sitting inside long, sunken valleys. The rift is not a single crack. It is a system. It stretches for roughly 3,000 kilometers, from the Afar triple junction near the Horn of Africa down toward western Mozambique. The United States Geological Survey describes it as the only rift system in the world that is active on a continental-wide scale, giving geologists a view of how continental rifts can develop into oceanic spreading centers, like the Mid-Atlantic Ridge. That is why East Africa matters. It is not just a valley, it is a laboratory. It is the kind of place where the story of an ocean can be read before the ocean exists.
The most important place in this story is Afar in northern Ethiopia. Look at it on a map, and the geometry is almost too perfect. The Red Sea Rift comes down from the northwest. The Gulf of Aden Rift reaches in from the east, and the East African Rift extends southward into the continent. 3 rifts meet in a Y-shaped system. Geologists call this a triple junction, The Geological Society explains that the Arabian Plate is rifting away from Africa along the Red Sea and Gulf of Aden. South of that, Africa itself is being stretched, splitting into the Nubian and Somali plates. This is why Afar is so unusual. It is one of the few places where you can stand on land and see a process that usually happens hidden beneath the ocean. The region is hot, dry, volcanic, and in places brutally low. Parts of the Afar Depression lie below sea level. In the long future, if the land between the plates keeps sinking, the Red Sea and Gulf of Aden could eventually connect through the rift system. The ocean would not appear because one giant crack suddenly opens. It would appear because the crust loses the battle slowly. It stretches, it thins, it drops, and then the sea comes in. For decades, geologists suspected that something deep below Afar was helping drive this process. A rising mantle plume, hot material from inside Earth, may be weakening the crust and focusing volcanic activity where the plate is thinnest. In 2025, researchers reported something even more visual. The mantle beneath Afar may not be uniform or stationary. It may pulse. The University of Southampton described evidence of rhythmic surges of hot mantle rock rising beneath Africa. The lead researcher, Dr. Emma Watts, said the mantle under Afar is not uniform or stationary, it pulses, and those pulses carry distinct chemical signatures. One co-author compared the chemical striping to a heartbeat. That image changes the story. Africa is not just being pulled apart from above. It may also be responding to surges from below. The surface and the deep earth are connected.
The rift does not move fast in human terms. In many places, the plates separate by only millimeters each year. That is slower than your fingernails grow. It is so slow that for most people it might as well be invisible. But geology does not need to move quickly to transform the world. Give a few millimeters enough time and it becomes kilometers. Give faults enough earthquakes and valleys sink. Give magma enough pathways and continents break. Most of the time, the East African rift works quietly. Then occasionally, it reminds us what it is. In 2018, a large crack appeared in southwestern Kenya and damaged part of the Nairobi-Narok Highway. Many headlines treated it as if Africa had suddenly begun splitting in half. The reality was more careful. The crack was a dramatic surface expression in a region already shaped by rifting, erosion, faulting, and seismic activity. It did not mean the continent was about to split tomorrow, but it did show something important. The rift is not an abstract line on a map. It is a landscape people live on. Roads cross it. Towns sit near it. Farms, lakes, volcanoes, and wildlife reserves all exist inside the same immense geological system. That makes the East African Rift different from the tidy diagrams in textbooks. It is not only a story about plates, it is a story about people, ecosystems, and the future shape of a continent. The rift has helped create some of Africa's most striking landscapes. Lakes sit in long basins carved by faulting. Volcanoes mark places where magma has found a path upward. Escarpments rise like walls on either side of sunken ground. And because elevation, rainfall, and geology all interact, the rift also influences habitats, water systems, and patterns of life. This is what astronaut photos and satellite imagery reveal so well. From above, the rift looks like a scar, but on the ground, it is a chain of worlds.
The future version of East Africa is difficult to imagine because it is so far away. But if the rift succeeds, the outline of Africa will change. The Somali plate, carrying the Horn of Africa and parts of Eastern Africa, would continue separating from the Nubian plate. The stretched region between them would thin and sink. Volcanic activity could create new oceanic lithosphere along the center of the rift. Eventually, seawater from the Red Sea and Gulf of Aden could flood into the low-lying basin. The result would be a new narrow ocean. Africa would become smaller.
A huge island or separated landmass could form to the east, including parts of Ethiopia and Somalia. The map of the planet would look different, but this future has to be handled carefully. It is not guaranteed in every detail. Continental rifts can fail. Some begin to open and then stop, leaving ancient scars in the crust. Even if this rift continues, the timeline is measured in millions of years, not news cycles. That is why the most honest version of the story is not, Africa is splitting tomorrow. The honest version is more interesting. Earth is showing us how continents die and oceans are born. We are used to thinking of land as permanent and water as fixed, but the planet is constantly rearranging itself. The floor of the Atlantic was once a wound between continents. The Red Sea is a young ocean basin. The Afar region may be another stage in that same planetary process. And the deeper scientists look, the more complex the story becomes. The rift is not just being stretched by plate motions. It is also shaped by heat, magma, mantle flow, rock chemistry, earthquakes, ancient weaknesses in the crust, and the way all of these forces interact across millions of years. The surface crack is only the visible part. The real event is happening through the entire Earth system.
There is also a misconception we have to leave behind. When people hear that Africa is splitting, they often imagine a single giant crack racing across the continent, swallowing cities, roads, and people. That makes for a dramatic thumbnail, but it is not how continental breakup usually works. Rifting is messy. It happens through networks of faults, basins, volcanic zones, earthquakes, and slow deformation spread across wide regions. Some sections move faster than others. Some sections are more volcanic. Some parts are young and broad. Others, especially near Afar, are much closer to complete breakup. That difference matters. The southern parts of the East African Rift are still relatively young. Faulting is spread out, volcanism is more limited. The north, near Afar, is where the system becomes more extreme. There, the crust is thinner, volcanic rocks are widespread, and the connection to the Red Sea and Gulf of Aden makes the future ocean idea easier to visualize. So the story is not one crack. It is a continent reorganizing itself from the inside out. That is what makes the East African Rift one of the most important geological places on Earth. It lets scientists compare different stages of the same process along one enormous system. In the south, they can study the early stages. In the north, they can see something closer to the edge of ocean formation. In Afar, they can investigate how deep mantle pulses, plate motion, magma, and surface faults work together. No other active rift system gives that kind of continent-wide view. And that is why the story is bigger than one future ocean. It is about how Earth renews itself. The continents we live on are not the final version of the planet. They are temporary arrangements of rock, floating, colliding, tearing, and drifting over deep time. If you could return to East Africa 50 million years from now, you might not recognize it. Where deserts and rift valleys exist today, there could be an ocean channel reflecting sunlight. The Horn of Africa might sit across water from the rest of the continent. New coastlines could cut through land that is now inland. Marine life could move into a basin that, in our time, was dry or volcanic ground. But that imagined future is only half the story. The present is just as extraordinary. Right now, East Africa contains a rare window into Earth's interior. It shows how heat from below can weaken the surface. It shows how plates begin to separate. It shows how volcanoes and earthquakes mark the stress of a continent under tension. It shows how the shape of the world changes long before the map catches up. And it reminds us of something easy to forget. Earth is not finished. The ground beneath us feels stable because our lives are short. Mountains seem eternal because we measure time in years. Coastlines feel permanent because the ocean is always there when we return. But to the planet, all of this is temporary. Africa is not simply sitting on Earth. It is part of Earth, moving with it, cracking with it, changing with it.
One day, the East African Rift may become a sea. One day, that sea may become an ocean. One day, the maps children study in school may show a blue line where today there are roads, deserts, lakes, volcanoes, and towns. And if that happens, it will not be because the planet suddenly broke. It will be because it had been breaking all along, slowly enough for us to miss it, but powerfully enough to redraw the world.